Good morning, and welcome to the first episode of Physics with Valerie. I need a ladder. Good morning. We are going to be discussing fields, namely electric and magnetic. But first, to properly understand fields, we must go over all of Coulomb's laws. The law of conservation of charge, kind of like the law of conservation of mass, charged particles, states that the initial number of particles inside an isolated system is equal to the final number of charged particles inside an isolated system. So no matter what happens, the number of particles in an isolated system stays constant. Now we are going to go over electrostatic force. Electrostatic force is a force that exists between two objects which have opposite charges or like charges. This force is also sometimes called the force of attraction, which basically just means that it is the force of attraction between two charged particles. This force can be modeled by the equation F is equal to K over R squared, where F is the force of attraction K is Coulomb's constant, Q1 and Q2 are the charges of the two particles, and R is the distance between the particles. For our first demonstration, we will be demonstrating electrostatic force. Please, put on your safety goggles for this very, very dangerous experiment. So how did that work? Why did my hair go up to meet the balloon? So, the physics behind that is that the balloon, which is made of rubber and is more prone to losing electrons, gains a positive charge. My hair, on the other hand, which is more prone to gaining electrons, gains a negative charge. And because, as Coulomb's first law states that opposite charges attract, the balloon will, of course, begin to attract my hair. While electrostatic force is the force of attraction between two particles, electric potential energy is the energy that consists between the two particles. It can be modeled by an equation very similar to that of electrostatic force, where U is the electric potential energy, R, again, is the distance between the two particles, the lowercase q is the test charge, and the uppercase Q is the charge of the object giving out the electric field. Not to be confused with electric potential energy, electric potential difference is the change in electric potential as the position of a charge in an electric field changes. If the object moved from here to here, what would be its change in energy?
As you can tell from this demonstration, when the electron is moved closer to the proton, the electric potential energy is lower, while when the electron is moved farther from the proton, the electric potential energy is higher. The electric potential difference between these 2 points can be found by taking the voltage of the second electric potential and subtracting the voltage of the first electric potential to find a final value of 7.72 volts.
The Lorentz force discusses the electromagnetic field of a charged particle, as is shown by the electromagnetic field lines around this proton. Ampere's law is used to calculate the strength of the magnetic field produced. Now we will move on to electromagnetism. The principle of electromagnetism is that moving charges produces an electric field. The direction of such an electric field can be found by the right-hand rules. The law of electromagnetic induction states that the change in magnetic force induces the electric current in a conductor. Directly related to this is Lenz's law, which states that the direction of the magnetic field produced is opposite of the direction of the field that produced it.
A real-life application of all these forces can be found in an electrostatic precipitator. How an electrostatic precipitator works is it passes the fumes from exhaust pipes in factories through a negatively charged wire. The electromagnetic field of this negatively charged wire is so strong that it causes the exhaust to be negatively charged. This negatively charged exhaust is then passed between 2 positive plates, making the negatively charged exhaust stick to the plates and sending out the clean air. This relates to all of the laws mentioned earlier. Electromagnetism and electromagnetic induction because of the electric field that is produced by the wire and it is induced into the gas. The Lorentz force, Ampere's law, and Lenz's law because we need to know the properties of the electric field of this wire so that this process may work flawlessly. One profession related to fields is a geomagnetist. A geomagnetist is somebody that collects data and does research related to Earth's magnetic field. Research is then used to study solar storms, and although that's also related to the sun's magnetic field, but geomagnetists study anyways. Geomagnetists are also able to locate natural resources that are underground, such as fossil fuels and some minerals. The education level needed to get this profession is a Bachelor of Science degree, which is a 4-year program, or if you want a higher position, then you would of course want to get a master's degree, which is another 4 years. The range of salary for a geomagnetist is anywhere between $66,000 to $129,000 per year. However, this type of salary depends more on the industry that you go into rather than the work experience you have. Going into a job related to education will put you on the lower end of that spectrum at around $66,000 per year, and going into the oil industry or other related industry would put you somewhere around $129,000 per year on average.